Welcome. Here we're going to take a look at a couple of other graphs, and we'll start with a stem and leaf plot. So stem and leaf plots are pretty easy to read, and it's just a nice way to organize data and save yourself a little bit of repetitious writing. So let me explain here. So I've got an example where the stem and leaf display gives the numbers of dinner orders on 18 different nights at a restaurant. So it even tells me how to read this graph. So with a stem and leaf plot, we're going to see a vertical line here separating what we call the stem of the number. So on the left of that vertical line, this is the stem. And then to the right of it will be all of our leaves. So sort of the branch analogy is the stem is like the bigger part, and then the little leaves, the smaller parts coming off of it. So here's how we read this graph. So if we see a 3 on this side and a 7 on that side, it means 37. So each of the leaves is one of the nights at the restaurant. So I'm just going to write these across the page. So one night there were 37 dinner orders. And then that leaf of 8 is 38. So that night there were 38 orders. And then there's another 8 there. So that night there were also 38 dinner orders. So the idea here with the stem and leaf is it saves us writing. So for example, let me do these. So 5 means 50 and then 2. So that night 52 orders. There was another leaf of 2, 52, and then leaf of 4, 54, and then 5, 55, and leaf 8 is 58. So rather than having to keep writing the 5 all the time, we just put it in the front, and then we tell people how to read that graph. And those are all of our dinner orders. All right, I'm not going to write them across the page for the remaining ones, but let's go ahead and answer these questions then. So on how many nights were the number of dinner orders in the 30s? So 1, 2, 3. So that occurred on 3 nights at the restaurant. And then what was the least number of dinner orders overall for these 18 nights? And so that would be the 37 orders. And then what was the greatest number of orders in the 50s? So there are our 50s, and that would have been 58 orders. Okay, and we'll just do one more here. So this stem and leaf displays the amounts of money in dollars spent by the Hartford family in their last 16 trips to Disneyland. And here's how we read this graph. So we have our stem and we have our leaves. So a stem on this side, 21, a leaf of 3 means $213 were spent. So I'll just go ahead and write this first set the long way. So that first one, 21 for the stem and then 3 for the leaf, that's $213. And then 21 for the stem, another 3 as a leaf. That's also a day of $213 spent. And then the 21 is the stem and a 7 as the leaf. That day, that visit, $217 was spent. All right, now we know how to read the graph. Let's answer the questions. What was the greatest amount spent overall? So that would be down here, 247. So 24 is our stem, and the highest leaf there is 7, so $247. What was the highest amount spent in the 220s? So that would be here. Highest there would be that leaf of 9, so 229 is the highest in the 20s. And then on how many trips were the amounts in the 230s? So the leaves here, 1, 2, 3, 4, 5, 6, 7, 7 leaves there. So there would be 7 values there. So for 7 trips, the amount spent was in the 230s. All right, and then we're going to look at one other type of graph here, probably the simplest one we'll ever see. It is called a line plot. It's also called a dot plot. So we will literally be drawing dots above a number line. And let me just go to the example here. So these are the number of minutes spent on hold for a sample of 20 customers phoning a technical support line. And I've gone ahead and put the numbers in ascending order for us just to make it easier to draw our graph. So we'll start with this first person on hold for 6 minutes. So we just go to 6, and then above the 6, we draw a dot. Let's make this a little bigger. Okay, and then I had a person on hold for 7 minutes, we draw a dot. And then another person on hold for 7 minutes, we draw a dot. And basically, you just stack the dots when we have repeats. So then I have an 8, a 9, and then I have 3 11s. So it'll be 11, 11, 11, and then 2 12s, 12, 12, a 14, a 15, and then 17, 19, 20, 24, 25, 25, 26, and 28. So I would like to give you more like 200 numbers instead of just 20, because kind of a small data set here. And we would generally not graph these by hand. You could have a computer help you out with this graph, as with many graphs. But just to get us started here, that is called a line plot or a dot plot. And what we're going to do is lead us into something that comes up in our next chapter. It's called measures of central tendency. So let me just introduce this word called the median and what it tells us. So a median, I think of it like the median in the road. It's the line down the middle of the road. So the median is the middle of the data set if your data set has been put in numerical order. So a median separates the data into 2 equal parts. So I have 20 customers here. So if I count 10 over, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I draw a line between the 12 and the 14, I would be right in the middle of that sorted list, and that's called the median. So it's the middle of the sorted list. Now it happens to be between a 12 and a 14, so the median, when we're between 2 numbers, we just average those 2 middle numbers. So averaging 12 and 14, I'm just going to add them and divide by 2. So that's going to be 26 over 2, or 13. So the idea here is that the median separates your data into 2 parts. So 50% of the data is to the left of the median, and then the other 50% of data is to the right of the median. And I can see when I graph it to scale on the line plot or dot plot that the median of 13 is here. So this is our median. So what I'm seeing here as our median is that these 10 numbers are in a smaller range, and then the other 10 numbers are more spread out. So as we go on and learn some new graphs in the next chapter, we're going to be looking at the distribution of our data again, and we'll be returning to this idea of the median splitting a data set into 2 equal parts. All right, and that ends our different types of graphs that we'll be looking at in this chapter.